Macedonia.
From where, I'm sorry?
It's Macedonia. It's like country in the Balkan, in Europe, near Greece. I guess everyone knows Greece.
Yes.
So it's above Greece.
Oh, that's good.
Yes.
So let's see if someone else entered to the room.
Okay.
Let's see some students. We have some students from several countries. Some of them speak
Okay.
Spanish, some of them speak English. So
I speak Spanish as well, so it's okay.
oh, that's good. How many
Yes.
languages?
No, I speak
Hi.
English, Macedonian. Hi.
Hi, Professor Nikolova. Great to have you with us today.
Yeah,
Thank
nice
you.
to meet you.
Thank you for
Yeah,
joining.
sure.
So we had the first session yesterday of
Okay.
this virtual event. It went pretty well. We had it for Spanish students. Roxana, can you check the link that was sent to the students just to make sure that it's this link? Because we had about 10 students confirm, but I don't see anybody yet logged in. Maybe we'll give them a couple minutes and then we'll start. We can also share this with them after the event. So we'll email our students kind of like a recording of the session, and hopefully they'll participate more in future sessions. But Emilia, you mentioned that you also speak Spanish?
Yes.
Wow.
Sí, hablo español también.
Oh, increíble. Muy bien. Bueno, okay. We have a lot
Oh,
of
that's good because we have bilingual students. So
yeah, we have a lot of versatility. In fact, most of our students speak Spanish. Maybe like 30% are English. So that's excellent. Okay. Roxana, if we're ready to begin, we can start. Did you check, is the link that we sent to the students, is it this link? Or did we send them a different link?
No, this is a link.
Is this one? Okay.
Yeah, I want one student here.
Okay, fantastic.
now.
Well, let's.
Worcy Francois. Hi, Worcy. Ahí está Worcy ya. Ahí pueden hablar con
Percy,
él.
how are you? Good to see you. We're about to begin. Well, Professor Emilia Nikolova, if you want, you can get started. We'll see how many of the points that we planned can be covered, and then we'll see if there's any questions or not. So thank you for joining us, and please go ahead.
Okay, so can you allow me to share screen?
Absolutely.
Yeah, thank you. Okay, so first we have like system of linear equation and inequalities. So I don't know, like the students. So this is like okay, so there are three ways to solve a system of linear equation and inequalities. The first way is by graphing the solutions. So first, let's write the ways that they can be solved. So first is with graphic. The second way of solving a system of linear equation is by elimination. And the third one is by substitution, subtracting y by the other one. So that will be like the third way. Sorry. I should have mixed. Okay. So the third way is by substitution. Okay, so this are the three ways that the system of linear equation and inequalities can be solved. So we will usually, like, as I teach, I will explain all of them, how to solve each of them. So, and then the students like will ask me, like, all of you can ask me, like, which one is not, what is not clear, what is clear, and which one is easiest to solve. So we have some examples here. I will do another share now. So we have one linear equation is given here. I think you can check my screen. I don't know how. Is it, can you see everyone good?
Yes.
Like the equation?
Yes,
Okay.
yes, it looks good, good to me. I can read it. Thank you.
Okay. So this is the equation. First, in order to solve like system equation by graphing, usually we do table in order to find the points for x and y in order to graph the first linear equation and then the second one. The solution will be where the two equations will intercept. So first we can make like tables. Wait, I will do that. Sorry, just 1 second. Okay, so I will do tables for x and y, and usually the values that we take are from -2 until 2. So -2, 0, -1, 0, 1, 2. So we have 1. So we have x, y. We have here, okay, the first one, -2, -1, 0, 1, and 2. So how we can solve it? I guess this topic is already known. So we need to insert the values for each of them into the equation in order to find the value y. So we enter the x value in order to find the y value. So in the first equation that is given is y equals to -1.5 times x. Instead of x, for the first one, we have x equals to -2. So instead of x, I put -2 here. So instead of x, this one. And then I add +4. So the only thing that I am changing is the x. So we will have y equals 2. Minus times minus give us plus. 1 times 2 is 2, and we have divided by 2. This is like we have 1 down. So we multiply the upper one and the down one. And we have +4, I copied from the first one. So then we have 2 divided by 2 is 1 plus 4 will give me 5. So the total result, y will equal to 5 for the first one. So we do the same for the second one, for x equals to -1. So I'll just like do it quickly here. So will be -1 times -1 over 2 plus 4, or will be minus times minus, again give me plus, it's 1/2 plus 4. 1/2 is 0.5, or we can do it like a fraction, but it will be 0.5 plus 4 or 4.5 in total. I'm just doing it quickly, not to lose time on this. I think this should be familiar to everyone how to solve it. So afterwards for 0, we have 1.2 times 0. We have the first term is 0, so the result will be just 4. For 1 will be the same here, just we will have minus times plus, so the result will be minus. So will be 4 minus 0.5, so will be 3.5. And then you can just see that like because the numbers like n x are in the rows. So this one are going down for the 0.5. So will be 5, minus 0.5, 4.5, minus 0.5, 4, minus 0.5, 3.5, and the last one, minus 0.5, will be 3. So they're just like in order. So now I can enter them in the graph. So we have minus 2 with 5, minus 2 with 5 will be here. Let me just. Okay, so minus 1 with 4.5, minus 1, 4.5 here. 0 with 4 will be here. And then we just need 2 points. No need to write everything, just to write like equations. So we'll come like this. This is the first graphic. We do the same one for the second one. So for the second one, we will have, so I'm doing the table. I guess this should be familiar to everyone how to fill the table. Like I assume everyone knows this, so I just like do it quickly. If anyone have questions, can ask. So x, y, I put the same ones, minus 2, minus 1, 0, 1, and 2. Now, instead of x in the second one, I put minus 2 for the first one. So we have y equals 2. 3 times minus 2. And then we have minus 3. So we have 3 times minus 2 will be minus 6. Minus 3, the result will be minus 9. So minus 9. For the second, we have 3 times minus 1 is minus 3. Minus 3 will be minus 6. For 0 will be just minus 3. So as we see, they're going like we're adding 3 for everyone else. So we have minus 9, then minus 6, then minus 3. For 1 should be 0, and for 2 will be 3. So they're like, they change for plus 3. So I can put just this one that I can find in the graph. You can just put 1 or 2. Usually with 0 is because it's the easiest one. 0 with minus 3. So I can do it with another color. So 0 minus 3. And then 1 with 0. So here. And then I graph it. So this will be the graph. So what is like here, we can find how much is, which point is actually the intercept of the both will be solution of this system equations, because we want to find the solution of the system of the equations. So the solution will be here with 2 and 3. So 2 and 3, we can read it from the graphic, is the solution of the system of equation. Is it clear, this one, the first one? Like the students? No? Anyone? Okay, so I can go with the second one. So let me share another one. Okay, now we have same graphic. I just want to explain something. So we have another system of equation that should be solved graphically. And in order to solve them, I can write down like quickly. So for example, for 0 for the first one, and for 0 for the second one, and one more, just to find the lines. So for the first table is for the first graphic. So for example, I will put 0, and we can put 2. And here the same. So when I put 0 in the first one, I will get, so for x equals to 0, we have 0 minus 4y equals to 12. Or I can divide the both sides by -4 in order to get how much is y. So we will get that y equals to -4 divided by -4 is 1, and 12 divided by -4 will be -3. So y will equal to -3. And then for 2, we will have 2 minus 4y equals to 12. So I need to subtract 2 on the both sides. So we will get -4y equals to 10, or just y will equal to -10 divided by 4. And that is minus 2.5. Let's do for the second one. So I have now the same for x. We will have for x equals to 0, we will have -4y. We have 0 minus 4y equals to 4. So again, I need to divide by -4 on the both sides. And we will have that y equals -4 divided by -4 is 1y equals to 4 divided by -4 is -1. And for 2, we will have I will write here. So we will have 2 minus 4y equals to 4. We subtract 2 on the both sides. So we will get -4y equals to 2. Or just y, we divide by -4 on the both sides will be -2/4. Or that will equal to -0.5. Okay, now for the first one, we have 0 with -3. So 0 with -3, that will be here. And the second one will be 2 with -2.5. So will be here. So we will get the line that is like this. And then for the second one, we have 0 with -1 and 2 with -0.5. So here. So now we get another line. And what can we notice from this is that both lines are, that means that the both lines will never intercept. So when the both lines never intercept, that means like that there is no solution to the linear system of equations because they will never intercept. They're parallel one to each other. And that's another way. Okay, so I think like this is the first way that I'm explaining, so system linear equation. So if with graphing, so I will go on the other methods. If everything is clear till now.
Yeah, this
Can
is
I-
really great, Professor Nikolova. It's very, very clear, and I love the
Okay.
graphics that you're using. So yeah, please
Okay.
go ahead.
Okay, so I can proceed with the other methods. So here now we can use like the second method that we mentioned, that's the method with elimination. So the elimination, we are eliminating one x or y from the first one or from the second one. So first we need to write them down in the same way. So if first one is 2x minus 2y equals to -2, we want the first one to be written in the same way. So in order to be written in the same way, we need to have -5x on the other side. So the both of them to be the other side. So I can write down here plus 5x on for the first one. So we have y equals to -5x plus 7. So I will just write 5 plus 5x on the both sides. So on the first side, we will have plus 5x or just 5x. Plus y will equals, we have -5x plus 5x, that's 0. So will equal to 7. And the second one will be, I just copy from above. So it's like this one is the system of equations. So I copy it here. So the second one will be 2x minus 2y equals to -2. So now, as the word says, is elimination. So we need to eliminate one or the other one. So in order to eliminate, first we check the easiest to eliminate is where in one of the equation, the number in front is 1. So like here, instead of y, it's 1. So I can like multiply the first one by 2, because here I have -2. And here, when I multiply this one by 2, I can, from first one, +2, and the second one, -2. So I can eliminate 1 when I add them together. So that's why in the first one, I'm adding 2. So, so the first equation, I multiply by 2. So I will just write down here because there is not so much space. So we will have 5x times 2. So each of the terms, I multiply by 2. So I have 5 times 2, that is 10x, plus 2 times y, that is 2y, equals to 7 times 2, that's 14. The second equation, I just copy it. So I just copy 2x minus 2y equals to -2. Now, because we have the same, like the opposite term in front of y, so I can add the equations together in order to eliminate y. So I have 10x from the first one plus 2x from the second one. Third. Okay, so 10x plus 2x. This one with this one we eliminate, so it's 0. Will equal on the other side, we have 14 minus 2. So we have 10x plus 2x, that's 12x, will equal to 12. So now we can divide by 12 on the both sides. And we will get x will equal to 1. So now this 1x that we got it, we can put it in the first equation here. So here, in order to find how much will be y. So we will have y will equal to minus 5 times, instead of x, I put 1 plus 7. So y will equal minus 5 plus times 1 is minus 5 plus 7, and that will equal to 2. So usually the children have problem with adding like stuff with different sign. So we take the sign in front of the bigger number and we subtract them. So the answer will be plus 2 or just 2. So now the solution of this system of linear equation will be x will be 1 and y will be 2. Is it clear?
Hey guys, great to see you joining us for the Zoom tutoring session. If you have any questions, feel free to ask. If you
Yes,
missed,
everyone, if they have like something unclear, can ask during the process, like when I'm solving every step of the way.
thank you, Professor Nikolova. And if you missed part of the session, if you arrived a little bit late, we will be uploading this so you can see it in the archive if you wanted to see it from the beginning.
Okay, so now I can go on the other one. So this was like, we solve now the same system. We just like want to show another like way that of solution that can exist. So this one we solve on the same way. Here, everything like we don't need to multiply the first one or the second one, because as we can see in front of y, one is minus 4 and the other one is plus 4. So they're already, so one and the other one, they're already like in order. So I can just add them together like in the beginning. So when I add the first one to the second one, I have 4x from the first one plus x from the second one. For the second term, I eliminate it. And on the other side, I get 4 minus 14. So we will have 5x equals to minus 10. Or just x will equal to minus 2. Okay? So here I divide by 5 on the both sides. So I get x equals to minus 2. And now in order now to find y, I can put in the first one or the second equation instead of x for minus 2. So I just put like this one. I can put it in the second one because we have just 2, so it will be easier to solve. So here. So we will be minus 2 plus 4y equals to minus 14. And then I add plus 2 on the both sides. And we get 4y equals to minus 14 plus 2. or 4y will equals to minus 12. Now I can divide by 4 on the both sides. So we will get that y equals to 12 divided by 4 is minus 3. So the solution will be minus 2, minus 3 of this system. Is it clear? So, okay. So let's go on the other one. Okay, so this one is kind of the same equation. So as you can see, the coefficient in front of x and y are the same. So we have minus 4 plus 3 on the first one, and we have minus 4 and plus 3 on the second one. So the first one equals to 3 and the second one equals to 7. So when they're both they're equal to different numbers, so that means that the system doesn't have solutions, because they cannot be like the same, like x plus y equals to 3 and x plus y equal to 7. You cannot find two numbers that will give you the same different solutions. Okay. Oh, sorry. Okay, so let's see like now the third. Wait, I think on this one. Okay, on this one, let's see like the, sorry, this one. So let's see here, like on the same equation, we will solve it by the last method that we, so the last method that we mentioned by subtraction. So we solve like the last equation. So that is y is equal on certain way. So in the second equation, instead of y, I put this term here. So minus 5x plus 7. I put it inside the equation. Okay? So we will have 2x. I will do it like. So we'll have 2x minus 2 times minus 5x plus 7 instead of y equals to minus 2. So 2x I copy. Now, when we have number in front of the brackets, I multiply with the two numbers that are inside. So this one I multiply by this one, and 2 I multiply with the second one. So now we have minus times minus, that gives me plus. 2 times 5 is 10x. And then for the second one, I have minus times plus, give me minus. 2 times 7 is 14. And that equals to minus 2. So now I add the both that are with x. So I have 2x plus 10x, that's 12x. Minus 14 equals to minus 2. So now I need to add 2 on the both sides in order to eliminate, like to add 14, sorry. To add 14 on the both sides in order to eliminate 14. And in order the number, like the constant with x, to stay alone on one side. So we will have 12x minus 14 plus 14, that will give me 0. And on the other side, I have minus 2 plus 14, and that will be plus 12. So we take the side in front of the bigger number and we subtract them, so it's 12. So now I can divide by 12 on the both sides. So we will have x equals to 1, or 12 times 1 equals to 12. So x is 1. Now again, I can add x equals to 1 in the first equation in order to solve for y. So we will have y equals to minus 5 times 1 plus 7. And then we have minus 5 plus 7, y will equal to 2. So again, solving on the other way, we get the same answer for the same problem. So x will be 1 and y will be 2. Is it this clear? Yes. Okay, so this is like the first, so this is like the first lecture that is about the system of linear equation and inequalities. So let me know from all of this that I speak, which one is clear, which one is not clear. Does anyone have questions? Is everything clear to everyone? Okay, so can I continue to the next one, to the next lecture, or you want?
Hi, Professor. Yes, please go ahead. I've been
Okay.
following on the chat, and I've been, letting the guys know if they have any questions to ask. But so far, I think you've been very clear. So
Okay.
thank you.
So the second one is polynomials and factoring. So let's see. So the second one is polynomials and factors. So we have like different here equation, how to multiply them. For example, I have like two terms. So 2x minus 3 times I have in the other one 3x plus 7 y plus 3. So now I need to multiply everything, the first term with the second one in order to get polynomial equation. So wait, actually here we'll do like 3x squared plus 6x minus, okay. So I have squared here. Okay, so what we do, so first we need to multiply first term with each of these terms. So now, firstly, I multiply 2x by the first one. So we have 2x times 3x squared. Then we have 2x times minus 6x. So we have plus times minus, give me minus, and I have 2x times 6x. Then we have 2x times 3. So plus, because I have plus here, 2x times 3. Then I do the same one with the second term. So the second term, you take it with the sign in front of it. So I have minus 3 in front. So you need to consider that minus. So I multiply the same with each of these terms. So we have minus 3 times 3. So I have minus, because I have minus times plus, that's minus 3 times 3x squared. Then for the second one, I have minus times minus, that give me plus. And we have 3 times 6x. And for the last one, I have minus times plus. That give me minus 3 times 3. So now I can multiply each of these terms. So I have 2 times 3, that's 6. X times x squared, that is x on third. I just add the exponents. On the second one, I have minus 2 times 6, 12. X times x is x squared. Plus 2 times 3 is 6x. Minus 3 times 3, that's 9x squared. Then I have plus 3 times 6, that's 18x. And the last one I have minus 3 times 3 is 9. So now, in order not to get this long polynomial, I need to sort them out. So how do I sort them out? Everything that is with x on the degree 3, I can add them together, or degree 2, degree x, just, or the numbers. With degree 3, so x on third degree, we don't have anything else, so I just copy it. So I put like 6x on third. And then with squared, I have 1 that is minus 12x squared, and I have minus 9x squared. So because they're with the same sign, I copy the sign and I add the numbers together. So 12 plus 9 is 21x squared. Now with x I have plus 6x plus 18x, and that's together is plus 24x, plus 24x. And now without x, it's just this the last term. Because there is not another one, I just copy that one too. So minus 9. So this is how we get, like, from 2 terms, we get in the end one long polynomial that is on the third degree, then second, then first degree, and the last one is free number. Is this clear? The first one?
Yes, very clear. Professor Nikolova,
Okay.
maybe if there's a time, whenever you would want to fit it in, sometimes there's a disconnect in math between the mechanics of solving the problem and what would be kind of a practical real world application, like under which circumstance would you, in real life, use some of the concepts that you've showed us today, including this last example. I think that would give some of our students kind of a understanding of the purpose and utility of these problems.
Yeah, so like usually like the graphics that we solve, like the equations that we solved before, usually they're used like if you're doing like computer science or you're doing like simulations and stuff, and you can use them like always like to find the solutions, usually the graphic solutions. So even if you're doing weather forecast or you're doing simulations, for example, to find out if there is like a river and you need to find where is like the where is more pollution in the river, so where you need to add systems and stuff. So you're using these equations in order like you solve problems and you find simulations by this, and you find where is like the optimal solution to find where you need to place that stuff. That's how the people like solve like usually engineering stuff. Like in engineering, they're most useful, as well in informatics and that kind of stuff. Okay.
Fantastic,
So,
thank you.
Yeah, you're welcome. So can I continue like with this, I guess, because for now they told me it's clear. So now we have like the terms that are like a plus b squared. Then you have when you have 2 numbers squared. So how we find the solution? That means that, as you know, when the number is squared, you multiply the number by itself. So that means that the term a plus b, I should multiply it by itself. So I should multiply by a plus b. And I multiply on this way, like I multiply the first term with the first one, so the first term with the both as well, and the second term with the both. So what we get is a times a will give me a squared, because it's a times a, or wait, I can write it down more simple first. So a times a plus the second one will be a times b now with the second term, so b, so now we have the b, so b times a and plus b times b. So we get for the first one, a times a is a squared plus a times b is ab plus b times a is the same one. We can write ba or ab is the same because we just multiply two numbers. It doesn't matter which one is the first one. And the second one is b times b, that's b squared. So now I have the first term, a squared, have 2, 1 ab, another ab, so that's 2 times a times b. And then the second term is plus b squared. So like this, we get the formula. So in order to solve a polynomial equation, so we need to find this. This is like the solution for it. So if we have, I will write them down here. So if we have a times b squared, the equation that we use is a squared, so the first term squared plus 2 times the first term times the second term and plus the second term squared, so b squared. Okay. We have the same one when instead of here plus, it's minus. So if we have a minus b squared. In this case, everything will be the same, just here in the second term, instead of plus, I will have minus. So it will be minus 2ab. And will be plus b squared. Okay, so I will solve one example. So these are actually formulas. They're really easy ones. So it's the first term squared, the second term squared, and 2 times the first and the second one. When there is plus, it's plus here. When there is minus, it's minus in the middle. So it's easy to remember. So I can erase this. So I can solve one equation like this. So when we have 9x plus 3 squared. So we have 9x. We square the whole term. Like, never forget, you don't square just the x, you square the 9 too. So now we have, because we have the plus sign here, I put plus. I have 2 times the first term, 9x, times the second term, times 3. And plus, I have the second term, that's 3 squared. So I will get 9 squared is 9 times 9, that is 81x squared. So 9 times 9, x squared, plus 9 times 2, that's Okay, so 2 times 3 is 6, 6 times 9 is 54. So I multiply the three numbers. So 54x and plus 3 squared, that is 3 times 3 is 9. So now I can rewrite the equation as polynomial. So I get this term. Okay, is it everything clear for now? I guess if anyone has to ask something.
Apparently, no one has any question right now. So I think we're all understanding the explanation.
Okay, so now we'll see like for taking term in front. So when we have 6x squared minus 3x. So now the point is like to find out if this one is equation, to find how much is the solution of this equation. If we have 6x squared minus 3x equals to 0. So when the equation is given like this, we cannot find actually solution. So the only way is we take a term in front. So what we take in front is the least common factor for the both of them. So for example, for 6 and 3, that will be 3. And from x squared and x, I take the smallest one outside. So I take 3x outside. And now inside, what I want to get is when I 3x, I multiply by the first term to get this one. And when 3x, I multiply by the second term here, I get this one as a result. So I can just divide this one, 6x squared by 3x. And then the second term as well. So minus 3x, I divide as well with 3x. And that will equal to 0. So we will have 3x in front. Inside we will have 6 divided by 3, that's 2. I can eliminate 1x, so we'll stay 2x. And for the second one is 3x divided by 3x, that will give me 1, because it's the same term. When you divide by itself, you get 1, and that equals to 0. So now I have two terms. So in order to find how much will be the solution of this equation, I need the both of the terms to get to 0, because here we have 0. So we have 3x equals to 0, and 2x minus 1 equals to 0. So 3 times whenever number I get equals to 0. So the solution will be x equals to 0. In order to get 0, 3 times 0 will give me 0. So this is the first solution. And the second one will be 2x. So here I have minus 1. In order to be 2x alone, I should add 1 on the both sides. So we will get 2x. This one I eliminate. And on the other side, I have 1. Now I divide by 2 on the both sides. So we will get 2x divided by 2, that's 1, or just x, equals to 1 over 2. So the both of the terms I divide by 2. So this is x2. This is the second solution of the equation. So we can see when we have polynomial equations of the second degree, we have two solutions of the equation. So the first solution will be x equals to 0, and the second solution will be x2 equals to 1/2 or 0.5. Is this clear? Or no?
Yes, Professor, thank you.
Okay. Okay, so that is like with this polynomial. So there is like another, sorry. So we have as well like system equation. There is like another way of solution. So the solutions can, like this, have two solutions. There is another way to have one solution when it's like the equation have just one solution. And then we have, we don't have solutions. So that will solve like when we have any type of linear equation, like 2x squared minus 3x plus 4 equals to 0. So in order to solve this system, there is like a rule that we follow, and that is x1 or 2, depends how many, equals to minus b plus minus Hi, sorry. Can you hear me? Like my internet went down.
It's okay. Yes,
Sorry.
I hear you. No problem. It's okay. I mean, I think we actually got right to the 1 hour 1 hour time interval.
Yes. So you want me to explain this one, like, I guess will be 5 more minutes, or?
Okay, sure. Yeah, let's please, if you can finish, that would be great.
Yes, sorry about that.
It's okay.
So x minus 2 will be minus b plus minus square root of b squared minus 4ac over 2a. So a is the second term in front of x squared. So this is a. B is the term together with the sign in front of x, and c is the free term with the sign as well. So this one will be c. So in order to solve this one, we will have x12 will equal, so we have minus b, so minus 3, because 3, I take it with the sign, plus minus square root of b squared, so it's minus 3 squared, minus 4 times, instead of a, I put 2, instead of c, I put 4, because we said c is 4. And down I have 2a, so 2 times 2. So x12 will equal to minus times minus is just 3, give me plus. So plus minus square root, minus 3 squared equals to 9, minus 4 times 2 times 4. So we have 8 times 4, and that's 32. over 4. Okay, so in this way, we will get that 3 plus minus square root of 9 minus 32 is minus 23 over 4. So now we have that the second term with the root is negative number. So when we have like this, when it's negative number, that means that the system doesn't have real solutions. So it doesn't have in the numbers, there is no real solutions. When this term determines if the equation have two solutions, one solution, or doesn't have real solution, that means that doesn't have like real number solution. So because now in this term is minus 23, so this one is negative, is smaller than 0, means the equation doesn't have like solutions that are real life, real numbers. So that said, I will just write down. So when we have like this term, AC is bigger than 0, we will have two solutions for this equation, xy1 and x2. And x1 we will get when we use the plus sign here, and x2 we will get when we use the minus sign. And when we have b squared minus 4ac equals to 0, that means that this term here, like this whole, will not exist because will be equal to 0. So minus b will over 2a, that will be the solution of the problem. And we will have one, it will be one solution. And now when the third term, it was b squared minus 4ac is smaller than 0, then we don't have real numbers that are solution of the problem. We have like I, but they're not in the real system. So the system doesn't have solution in this way. So I think like this, we covered the both lessons. Like, I don't know if you have like any questions. If someone has any questions.
Thank you, Professor. Yeah, I mean, I think something happened that everybody got logged out. I think it happened at 11 o'clock, like at exactly the 1 hour. So I think we have to check the settings, the settings on the Zoom. Maybe because the hour was up, it kind of kicked everybody out. I don't know how we ended up just you and me, but I can't even put my video now. So I don't know, but we'll check it for next time. Okay. I really like this interaction with the students because right now,
exactly.
Students,
usually like when I solve like this, I don't like do the whole explanations. I ask like the students to interact when I'm solving it. Like, that's why I ask, like, I don't know how you solve usually, but usually I don't solve on this way, me talking all the time.
Right.
Usually I ask them to tell me what to do because to see how much they progress.
Yes.
But we'll see. It's the first time, so I don't know.
Yeah. We'll see. Yeah, maybe they get more comfortable with the next sessions, but I mean, I would, we're trying to do this at least, once a week to give the students who want to learn like this the opportunity, because right now everything is like, pre-recorded lessons and examples that are pre-recorded and then the little quiz or test. So I like having this opportunity for the students. I would like to repeat it if you're available. And
Yes, I think like the students, like they should like specify what they have problem and we can focus exactly on that problems.
Okay.
And because honestly, I think this is too much for 1 hour. Like I try to cover it like the best, like quickly, but usually like this, for example, the first one with the graphic, I'm usually doing the graphic one class, another class, just the other way of solving. So
well, we're also complementing, like, for example, these two exercises that you did belong to specific lessons in the math curriculum. So when a student is stuck in the math curriculum, we can complement them with this recording. So it kind of adds to the lesson that they're on. So if this is for lesson 9, we will give them access to this video, and sometimes they have questions and this video might solve it for them. But
Okay.
we really want to have something that's an element of being live. So I think having maybe once a week or something like that, or once every, at some frequency, it would be great. And the other question I wanted to ask you with is, I don't know how your schedule is, if it's kind of open or sporadic. We have students sometimes who call in with specific questions about, you know, a math problem or something like that.
Yeah, that's why I asked.
And I don't know
Usually,
if,
like, prefer.
if I don't know if we can set up with you maybe some availability, maybe a couple of hours a week, where if a student calls in, maybe we can say, hey, Emilia, this student would like to have a little bit of help with math, and maybe we can assign, I don't know, 30 minutes or something of one-on-one
Yeah, okay.
one-on-one tutoring. I don't know how your schedule is. Maybe that's not possible because you have other commitments, but it would be great to
I
offer
can do
that.
it like, usually I can do it like this, like after like this, like 10 p.m. 10
Oh, perfect.
a.m. for you,
That's perfect,
like
because
mornings,
Yeah.
morning.
perfect. Most of our students are in the Americas, you know, North America, South America, Central America, and you say you speak Spanish, so I mean that's super.
Yes,
super
like
good
I
for-
need to practice. I need to practice with math more, but like I
Okay.
speak the other stuff like good.
Okay. Okay. Perfect. Well, thank you so very much for being
Yeah,
on
thank
today.
you too.
It was a great success, and thank you. And I'll contact you again to schedule the next one and see if you're available.
Okay,
Thank you
thank
so
you.
much, Emilia. It's a pleasure.
Okay, pleasure.
Ciao.
Bye.
Bye.
Okay,
you.
thank
Bye-bye.
you.
Thank you too.
Thank you, Nell. Thank you, Sebastian.
Thank you. It's been awesome.
Thank you.